Okay. So, first and foremost, I know that kita tak kenal each other kan, and it will be too long kalau kita nak buat ice breaking. So we'll save that for second semester when kita actually jumpa. Okay? So right now saya nak tanyalah. You guys comfortable? Alamak, ada orang tak boleh tengok stream lah. Stream ada limit ke? Do anyone know how nak buat, ada limit ke tak?
Ada, sampai 50 orang je.
So anyone know tak kalau macam nak increase the limit? Ada tak siapa-siapa yang tahu Discord ni? Saya pun baru guna Discord ni. Tak tahu Oh, Nitro yang kena bayar tu kan? Okay lah. Some people tak boleh nak tengok kan. So to be fair, sorry, the class will be a bit late. I akan buat kelas dekat Google Classroom. I'll give you Google Meet. I'll give you the link. Sekejap Okay, sekejap. I'll make the Google Meet and then you guys masuk nanti. And nanti later, can you guys stay dekat Discord? Because I nak ambil attendance nanti.
Okay.
Okay, sekejap Okay. So here's the link. I'll give you the link. You guys comfortable kalau I ajar fully English or mix or a lot of Malay ke?
Mix.
English pun boleh.
Okay.
Sebab dah biasa.
Korang dulu during the high school belajar Malay ke or English?
English.
Oh, okay, good. Because some school belajar Malay kan? Okay. So don't worry, the terms, okay, benda-benda yang perkataan ke apa semua yang penting-penting tu is everything in English lah. There's no way nak buat bahasa Melayu because nanti exam pun akan English. Tapi the explanation I can lah terang in Malay and mix lah. Okay. So later I will okay, dalam Google Meet ni kita mute lah semua. I'll talk in Google dalam Discord. Okay. Untuk Google Meet ni just untuk I show my slide je. Banyaknya orang masuk. Okay, berapa dah ramai? Baru 46 people. Anyone yang tak masuk lagi? Okay, any question ke nak cakap ke apa semua kita through Discord Untuk Google Meet we just tengok ni je, tengok my slide. Okay, baru ada 64 people. Okay, I hope the other now ada 70. Kita have around 17 people lagi yang tak masuk. Okay. So everyone can see the slide ke tak dekat Google Meet ni? Boleh nampak tak?
Boleh, sir.
Okay, good.
Nampak, sir.
Boleh, sir. Boleh.
Okay, good. So we wait one more minute. 10 we'll start. Ada a few more people yang nak masuk. Okay, so I think we should start the class lah. Okay. So, first chapter in chemistry yang you guys akan belajar is matter. Okay. Let me present this. Okay. So, during high school dulu you guys belajar pasal matter, right? So, you guys belajar pasal solid, liquid and gas. Actually, this is a bit further than that, and you guys actually dah belajar actually dekat I think form 4 if I'm not mistaken. So let's first tengok video ni dulu. Okay, have you ever wondered what are the world made of? So kita tengok apa yang the basic building blocks of dunia ni lah yang kita duduk.
Atoms are ridiculous and unbelievably small. A single human hair is about as thick as 500,000 carbon atoms stacked over each other. Look at your fist. It contains trillions and trillions of atoms. If one atom in it were about as big as a marble, atoms are ridiculous. Look at your little finger. Imagine that its tip is as big as the room you're sitting in right now. Now, fill the room with grains of rice. One rice corn represents one cell of your fingertip. Now let's zoom in on the rice corn. And now, one cell is as big as the room you're in right now. Let's fill it with rice again. This is about the size of a protein. And now, let us fill all the empty spaces between the rice corns with fine grains of sand. This is roughly how
Oh, tak ada bunyi Sekejap Let me do this. Okay, I'll pasang the bunyi to my mic. I hope you guys boleh dengar lah.
how small atoms are. What is an atom made of? Let us just pretend that atoms look like this for a minute to make it easier to understand. An atom consists of three elementary particles: neutrons, protons, and electrons. Protons and neutrons bind together and form the atom core, held together by the strong interaction, one of the four fundamental forces in the universe. They are made from quarks and held together by gluons. Nobody knows exactly how small quarks are. We think they might literally be points, like in geometry. Try to imagine them as being zero-dimensional. We suspect that quarks and electrons are the most fundamental. Is actually a space filled by quantum fluctuations, fields that have potential energy and build and dissolve spontaneously. These fluctuations have a fundamental impact on how charged particles interact, but that's a topic for another video. How much space do the core and electrons actually fill? If you were to subtract all the spaces between the atom cores from the Empire State Building, it would be about as big as a rice corn. All the atoms of humanity would fit in a teaspoon. There are extreme objects where states like this actually exist. In a neutron star, atom cores are compacted so densely that the mass of 3 suns fits into an object only a few kilometers wide. By the way, what do atoms look like? Well, kind of like this. Electrons are like a wave function and a particle at the same time. We can calculate where an electron might be at any given moment in time. These clouds of probability, called orbitals, are where electrons might be with a certainty of 95%. The probability of finding an electron approaches zero the further we get away from the atom core. But it actually never is zero, which means that, in theory, the electron of an atom could be on the other side of the universe. Okay, wait a second. These strange thingies make up all the matter in the universe. For many dozens of known elements, you don't need many dozens of elementary particles, just 3. Take one proton and one electron, and you have hydrogen. Add a proton and a neutron, you have helium. Add a few more, you get carbon. A few more, fluorine, even more, gold. And so on. And every atom of an element is the same. All hydrogen atoms in the universe, for example, are the same. The hydrogen in your body is exactly the same as the hydrogen in the sun. Do you feel confused right now? We certainly do. Nothing on this scale of the universe makes any sense in our world, and we've not even begun talking about quantum mechanics or the particle zoo, which are even stranger. Our model of atoms has changed a number of times since we first conceived it, and the current one will certainly not be the last. So, let us support scientists and research and wait for the next wave of mind-boggling new information about this strange world that is the basis for our existence. Atoms.
Okay, everyone nampak ke tadi? Dengar kan? So, what we're gonna learn, chapter 1 and chapter 2 is basically, kalau you tengok tadi ada model kan? Kita ada Bohr dengan quantum mechanics. Dulu masa sekolah menengah, you guys ada belajar pasal models kan? Atomic models kan? Ada banyak-banyak tu kan? Ada Rutherford apa semua tu. For matriculation, you guys gonna focus on 2 je. So we akan tengok Bohr, and nanti kita akan tengok quantum mechanics. Okay, yang kalau tadi kita tengok, dia ada cakap kalau electrons, protons, neutrons semua tu ada dibuat oleh gluons dengan apa lagi tu kan. But now kita hanya fokus on proton, neutron and electron. So if I'm not mistaken, my learning outcome ni learning outcome yang lama. Okay, follow the learning outcome yang ada chemistry checklist tu yang Encik Farid ada bagi. Kalau siapa tak ada tu, I can give it later. I can give it again. So, few more people are coming in. Okay lah, 80. After that, I can start my class. Okay. Okay, so learning outcome. So basically, how you guys nak tackle matriculation. So matriculation, you guys nak tahu soalan apa yang akan keluar in the exam. You guys look at the learning outcomes. Okay, this is the learning outcome ni is not accurate lah, is yang lama. Tapi mostly the same. Okay, for example, define proton number Z, neutron number A and isotope. Okay, to be honest, soalan matriculation is about the same every single year. Almost the same. Dia tukar-tukar every 3 or I think every 2 or 3 years. So kalau you guys dah buat past paper, you guys akan nampak the trend. For example, kalau chapter 1.1 dia cakap you punya learning outcome is define proton number Z and neutron number A. So maksudnya dalam exam dia akan tanya pasal contohlah oxygen, dia akan tanya dia punya proton number as such. Okay, learning outcome is how you wanna study smart. You tak perlu study everything. You study on learning outcome. You tengok you boleh achieve the learning outcome, it means that you already ace the topic lah. So okay, what is the smallest thing that you have seen today? Benda paling kecil today. Ni you guys bangun tidur, sarapan dah. Dah breakfast ke semua?
Dah sir.
Okay, what's the smallest? Okay.
Dah sir.
Good. Okay, dah breakfast maksudnya everyone has energy lah kan? Okay. Get excited. We're gonna learn a very fantastic thing today, okay? So, this is the smallest gun in the world and this is the smallest teddy bear. It's the biggest of, is as big as your fingernails. Or maybe the X on the mobile app. Kan? You guys main game, keluar mobile apps. Kecil kan? The X. Okay. So, atomic model. Okay, what what you guys need to know in atomic model. Let's give an example helium atom. Helium ada dalam balloons. Kalau you guys pergi maybe Jom Heboh or what is it? Maybe a carnival. You guys have those balloons yang terapung kan? Inside of those balloons we have helium. So this is a simplified version of helium atom. Okay, you guys ambil microscope, you guys look at very deep inside of the atom. You guys supposedly this is what you guys akan nampak. In the middle we have dia punya nucleon. Okay, so nucleon we have neutron and proton, where dekat outside kita ada electron orbiting it. Okay, so we have the nucleus, which is have proton and neutron and electron dekat keliling dia lah. And before this we thought that electron always spin around the nucleus. Okay, this is the very basic model that we known lah, but nanti kita akan tengok where it is not actually true. So this is the nucleon number. Kalau orang tanya, it is the nucleus, and proton number usually kita akan ada dalam nucleus, and I can show you that proton number nanti adalah sama dengan electron. Okay, this is the subatomic particle of an atom. So apa yang nombor banyak-banyak ni? So nombor banyak-banyak ni you guys tak perlu nak hafal banyak sangat pun. Usually dia akan be given. Kalau dalam question dia akan be given. But just know that, okay, just know that just know that proton has a charge of positive 1 and electron has a charge of negative 1. Okay, kalau you guys tengok ini pun kan, nampak tak? Ada yang positif, ada yang negatif. Okay, and then the other stuff yang you guys have to take note is dia punya mass. Okay, mass of proton and neutron. Okay, mass of this stuff dekat tengah ni. Okay, make up the mass of the atom. Okay, tapi I'll show you why. Okay, so let's see proton number and nucleon number. You guys dah belajar dah benda ni masa sekolah menengah, so I'll go quite fast lah. So proton number, what is proton number, what is nucleon number? So benda yang selalu common mistake in exam is you guys tertukar lah. So let's first kita tengok proton number. So proton number, like of course lah, dia punya definition is the total number of proton dalam nucleus kan. Okay, also known as the atomic number. Okay, if you guys look at you guys punya tutorials, dah download ke tutorials? Okay, dalam tutorial you guys bawah before masuk chapter 1 dia ada nombor-nombor, ada table, and then ada all the apa constant kan. So kalau you guys tengok, dia ada beritahu atomic number dengan atomic mass. Okay, nampak tak? So don't worry, on each atom dalam exam you guys tak perlu hafal dia orang punya atomic number. So atomic number is always given, and you guys know that atomic number is proton number. So apa yang dia cakap ni? In neutral atom, the proton the number of proton sama dengan number of electron. Okay, kenapa? So let's see. Okay, contoh tadi helium kan. So helium dia ada dekat dalam tu dia ada dua. Sekejap Okay, dia ada dua proton. Okay, and then dia ada dua neutron. Mana? Saya tak nampak. Okay, here. Okay, this is the basic model lah. I just show. And then dia ada dua electron. So this is helium lah. So this is the nucleus. Nukleus dekat tengah-tengah tu and dekat luar tu is electron. Okay. This is nucleus. And this is electron. Okay. Kenapa? Dia cakap in a neutral atom, the number of proton sama dengan number of electron. Okay. Kalau you tengok, proton dia ada charge plus 1. So, kalaulah dalam nukleus dia ada 2 proton, maksudnya dia plus 2 kan? Okay. And then electron pula, dia charge dia negative 1. So, dia ada 1 elektron, dia ada lagi 1 elektron. So, kalau you tambah everything, dapat berapa? Negatif 1 tambah 2 tambah negatif 1. Dapat tak? 0. Okay. So, in a neutral atom, okay, neutral, maksudnya the electron dengan neutron, dia orang have the same amount sebab dia orang cancel each other. Barulah stabil, barulah kosong. Okay. And then, kita akan go to nucleon number. Nucleon number is also known as dia orang punya mass. So, atomic mass. Tadi neutron tadi proton number kita known as atomic number kan. Untuk nucleon number we know as atomic mass. So it's a total number of proton and neutron in the nucleus. Kenapa kita cakap it is atomic mass? Kenapa kita tak masukkan dengan elektron sekali? Okay. If you look at this and this, perbezaan antara 1.675 times 10 to the power negative 24 dengan 9.1095 times 10 to the power 28. Okay. If you look at this, okay, 1.675 times 10 to the power negative 24, okay, okay, this is mass of proton ataupun neutron and this is mass of electron. Okay, if you look, kalau you tengok dia punya perbezaan, mass of proton dengan neutron is around 1.8k times the mass of electron. So it doesn't mean that electron tak ada mass. It's just that in an atom, kita only consider the proton and the neutron as the mass. So it is kind of like a grain of sugar versus 2 kilogram rice. So imagine the mass of the electron is this, and the proton or neutron, okay, this doesn't mean anything, okay. Proton or neutron is around 2 kilogram rice. Berat kan? So, kalau dalam atom kita dah tak consider pun berat elektron tu. That's why it is also known as the atomic mass. So, the mass is in gram ni, you guys don't worry, tak perlu hafal. The mass in gram ni kita akan diberi dalam exam. The thing that you have to know is mostly proton and neutron is way heavier than electron, and proton ada plus 1, electron ada negative 1. That one you guys have to remember. So okay, isotopic notation. What is isotopic notation? So this is how kita tulis kalau dalam maybe dalam lab or anything yang korang nak buat research nanti, you guys akan tulis like this lah. Sebab takkanlah nak every time nak refer to the table. So where is at is the element symbol, proton number is dekat bawah, nucleon number dekat atas. Okay. Sometimes some books, okay, some books also have like this. Dia orang tulis macam ni, A and then Z. Okay, let's see. Okay, that's the question. Some books, okay, contohlah kita do carbon. Can we do carbon? Okay, so untuk carbon, macam mana nak tulis dia punya isotopic notation? Okay, first kita akan tulis dia punya element. So So elemen simbol dia, you guys boleh refer dekat periodic table ataupun yang saya bagi tu, which is carbon. So and then kita akan tulis dia punya proton number. So proton number, so dia bagi 6 dan 6 kan. And then what is nucleon number? Nucleon number adalah number proton plus neutron. So 6 tambah 6, 12. Okay, boleh. But some books, okay, some question diorang sahaja nak trick you guys. So what they did is diorang tulis like this. Okay, is this salah or not? Betul ke salah? Okay, ada ke orang lagi dalam my lecture ni?
Salah, sir.
Okay, actually this kind of how we write this is also true. Okay, some books diorang saja memang sahaja nak trick korang. So korang tengok pun alamak 12, terus elektron dia, proton dia adalah 12. Lepas tu nukleon dia 6. Salah. Okay, even though diorang tulis macam ni, it is actually betul. The one yang you guys always have to think, okay, tengok tak, nukleon number dengan proton number. Nukleon always, the definition of nucleon number is proton tambah neutron. So doesn't matter lah, doesn't matter lah ditulis bawah ke atas, the bigger number is always nucleon number. So nucleon number always is the bigger number. Doesn't matter it is atas ke bawah. Okay, boleh. So now let's okay, now let's do untuk oksigen dengan fluorine. So oksigen and fluorine. Okay, ada tempat kosong kan dalam korang punya lecture notes? Try to do it.
Ada.
So remember that the biggest number is always nucleon. Doesn't matter di atas atau bawah. But it's just that usually the way kita tulis is like this lah. Kita akan tulis, this is the most common way. I'm just saying that jangan terkejut nanti ada buku atau soalan dia letak macam ni. So korang terus buat careless mistake, terus ambil 12 tu as the proton number. Okay. So in the interest of time, I akan tulis lah untuk, so oksigen you guys should dapat 8 tambah 8 is 16. And then untuk fluorine, dia punya proton number is 6. And then dia punya neutron number is 16. Okay.
So, saya rasa yang fluorine itu proton number ialah 9. Sebab fluorine from group 17, right?
Yeah, I'm sorry. Fluorine is 9. Fluorine is 9. Okay.
Oh, okay.
Thank you for correcting me. Okay. Thank you for correcting me. So it is 9. And the 9, the neutron number is correct. It's 10. So it is 19. Okay. So based on this, you guys boleh nampak actually the mass is here. This is the mass and this is the number of electron. Sebab dalam a lot of things, those are the two things yang kita mostly use. Mass and number of proton. Kan tadi saya cakap the proton number is equal dengan the electron punya number. Right? So dia orang positif dengan negatif, dia orang cancel each other kan? So number. So from the isotopic notation, you can know the electron number. There's a lot of things we can do with the electron number. Okay, we know a lot of things from dia punya how many electron dia ada. And this is dia punya atomic mass. Atomic mass where kita boleh buat banyak pengiraan juga. Okay, boleh. So now let's go on. Apa itu isotop? Tadi cakap isotopic notation. And apa pula isotop? So isotope is two or more atoms that with the same element that has the same number of proton but different number of neutron. Aduhai, peningnya dia punya description ni. Pening kan? So what does it mean is number of proton, okay? Dia punya number of proton is the same. Proton dia sama, tak berubah. The only thing yang berubah is, kalau you tengok, dia punya nucleon number. Okay. Dia punya yang berubah is, kalau you tengok, nucleon number is proton tambah neutron kan? Nampak tak? So, benda yang berubah cuma bilangan neutron. So, this one ada 1 neutron. This one ada, this one ada 0 neutron. 0 neutron. This one ada 1 neutron. This one ada 2 neutron. Okay, boleh. So, kalau you guys tengok, dia cuma bertambah neutron. Okay, what's the effect of neutron dia bertambah? What happened? So, what does this number means? Number ni yang atas ni maksudnya apa?
Nucleon.
Yes, nucleon, and also nucleon adalah apa dia?
Atomic mass.
Yes, atomic mass. So, maksudnya isotop yang berbeza-bezanya is dia punya nucleon number and also dia punya atomic mass. Atomic mass dia juga berbeza. Okay. So, this is yang tadi apa yang saya cakap tu. Okay. I think this one ada dalam you guys punya lecture note juga, and let's you guys, I give you 1 minute untuk siapkan dulu, and then let's do it together. Okay, nanti nak you guys bagi tahu apa dia punya jawapan. Okay, remember the nucleon number is always the biggest number. Number yang lagi besar. Okay, dah ke? This is not that hard. This is apa yang you guys perlu tahu is you guys baca where this is the element yang kita tengah tengok. Nombor ni nombor apa, nombor ni nombor apa, and ini ada apa pula? Tak apa, ini kita akan tengok later. Okay. So what's the proton number for Hg ni is mercury. Hg is oh my god, mercury. Okay, yang dalam thermometer korang tu. Nampak tak yang thermometer ada macam like liquid yang nampak macam metallic? That is mercury. So, berapa proton number dia?
80.
So, 80. Okay, neutron number nak dapat macam mana?
120.
120. 120.
Yes, 120. So everyone know kan macam mana dapat 120. 120 is 200 tolak 80. Sekejap ada orang nak masuk ke kelas ni. Okay. So and now electron. So electron dapat berapa? Electron sebabkan dia neutral.
80.
Yes.
80.
Okay. Sebabkan dia neutral atom. Okay. Kalau you tengok dua ni adalah charge atom. Kita akan tengok how. So let's go quickly. So this one should have 29 protons. This one should have 8 proton. Number paling kecil. And this one is 27 proton. Okay. Untuk neutron this dapat berapa? 63 minus 29 dapat berapa?
34.
4. Okay.
34. 34.
So the electron is still the same number dengan proton ni kan? Okay. Same number. Sebab dia adalah neutral atom. So let's look on this. So this cakap neutral atom kan? 0 sebab dia neutral. So let's look at oxygen 2 minus. Okay. Berapa dia punya neutron?
9.
9.
Yes, 9. But now, dia ada charge. Okay? Dia ada 2 minus. So, kalau dia adalah neutral, dia 8. It should be 8 electron lah. But now, it is not 8. Okay. Macam mana kita nak tahu berapa elektron dia? You guys tengok. Okay. Kalau minus and plus. Okay. Cara senang you guys nak ingat kalau charge. berapa banyak elektron dia. Kalau dia ada negatif, maksudnya dia telah mencuri elektron. So dia dah store an electron. Okay. Kalau dia adalah positif, maksudnya dia dah donate an electron. Okay. So kalau dia ada 2 minus, maksudnya dia dah curi 2 elektron. So initially dia ada 8 elektron, kan? And then dia curi 2 elektron. So what happened? Should get 10 electron, kan?
10 electron.
Nampak tak? So the charge maksudnya dia so basically like sin lah, dia punya dosa. Dia punya dosa dah jadi 2 minus. So dia dah berdosa 2. Dia mencuri 2 elektron. Kan? Okay. So how about the copper? So copper dia ada 59 minus 27 dapat berapa?
32.
32.
32. And then initially dia ada 27 electron. And now dia dapat
24.
so dia dapat pahala lah 3 plus. Dia dah donate 3 elektron dia. So tinggal 20.
24.
Yes, 24. Okay, boleh. Okay, everyone is clear dengan this? And nak continue? Okay kan?
Sir,
Ya? Ada question ke tadi?
yes.
Okay.
If charge, can we write like 2 negative and 3 positive? Or should we write negative 2?
Yes, you can write either way lah. You can write to like this or this. So it's just that the way I write it is like a charge of an ion lah. Kalau dekat element you never write. Contoh you never write like this. You always write like this. Okay? It's just the way that people write it. But it's okay, you can write it like this. Doesn't matter kalau dekat charge dia. Dia tanya charge dia berapa? -2. Yes, you can write -2. Okay, boleh.
Okay, thank you, sir.
I'll go a bit faster sebab I think we are running out of time. So, now kita akan tengok relative and average atomic molecular mass. Macam mana actually people timbang the small atom. Macam tadi kita tengok is super small, it's smaller than your hair. Kan? So macam mana diorang timbang? Diorang don't actually timbang. Okay, spoiler alert, diorang tak timbang. But diorang compare with carbon 12. Okay, kenapa diorang compare dengan carbon 12? Okay, carbon 12 is the most abundant element on earth. Okay, dalam badan kita pun dah mostly made of carbon. Kalau you ingat, we are carbon based organism. Carbon you can find it anywhere. Dekat pensel you, dekat tanah, pokok, kucing you, anjing you. Most of them have carbon. Okay, you punya charcoal, carbon. So what they did is diorang tengok average mass. Nanti kita tengok macam mana diorang tengok average mass tu, and diorang divide by 1/12 mass of atom carbon 12. Okay, kalau molekul pun sama je. This is, kita akan tengok macam mana. This is just like a formality supaya you boleh buat. Nanti soalan dia akan tanya, jawapan dia akan sama. Dia cuma akan test you punya knowledge je. Yeah, we will see how the question. Okay. Contohlah example oxygen. Dia bagi mass dia is 16 AMU. Okay. Kalau you tak, contohlah this question dia tak bagi tahu dia punya mass. Mana korang nak dapat dia punya mass? Dalam buku tutorial tu ada table kan? Table of atomic mass and diorang punya atomic number. That one is always given dekat you dalam exam pun ada. Dekat depan question paper. So don't worry, you guys boleh tengok oxygen. tengok dia punya atomic mass. So atomic mass dia is 16 AMU. So mana my cursor? Okay, sini. So relative atomic mass ataupun AR. So AR is a singkatan for relative atomic mass, is equivalent to dia punya average atomic mass, okay, divided by 1/12 times mass of carbon 12. Okay, formula ni, kalau soalan macam ni, you guys kena tulis formula because this formula will give you 1 mark. Okay, any question, tulis formula dulu baru you start jawab. Because sometimes the question, even though you tak tahu nak jawab, you have the correct formula, you will get mark. Okay, so cara dia, so average atomic mass. So the average atomic mass of oxygen is 16 AMU kan. Okay, and then dia cakap 1/12 times mass of carbon 12. So you tengok carbon, mass of carbon is 12 AMU. Okay, this is just a form. Why I said it is just a formality, because kalau you tengok 12, so 1/12 times 12 dapat 1 kan. AMU bagi AMU. Okay, this is the answer. So the answer, this is the answer. And take note that untuk relative maksudnya kita compare dengan carbon. So the relative mass of oxygen compared to carbon, or any atom yang compared to carbon, dia tak ada unit. So no unit. Okay, no unit. Tak perlulah tulis no unit ni. This is your punya final answer, 16. Okay, boleh. So this is very simple. It's just that,
So kalau
yeah,
if I just write down the final answer for 16, tak ada formula saya tulis, boleh tak?
okay, it's depend untuk question. So later we have time, I'll show you how to tackle the question. Sometimes the question macam ni, dia akan bagi like 1 mark. Okay, question dia 1 mark, you letak AR equal to 60, you dapat 1 mark. Okay, sometimes the question is 2 mark, so it's very generous to you. So this 2 mark maksudnya dia nak tengok you ada formula. So 1 mark for the formula, 1 mark for the final answer. So always kalau nak jawab question, look for the mark. So kalau 1 mark ni, you bolehlah terus buat. My suggestion is always buat the full one, okay, to make sure you get the full mark. Because sometimes kalau tiba-tiba lah you letak 16 and then suddenly you punya final answer is maybe you tersalah, you tulis 15. Some examiners will give you a mark because they know that you know how to answer it, just that you tersalah tulis. Okay, that's why I kalau boleh,
Okay, thank you, sir.
you buat full. Okay.
Okay, thank you, sir.
Okay, so let's go. Let's calculate the relative molecular mass of C5H5 and N. So macam mana calculate? Dia minta relative. So yang dia bagi is average. So molecular mass. So molecular mass of C5H. Okay, yeah, sorry. You should not do this. Okay. Kejap Okay. So, dia dah bagi AR. So, apa tu AR? AR is already dah relative atomic mass. So, cara you nak calculate molecular mass, relative molecular mass of C5H5N. So, macam mana nak buat dia? Is, okay, you tengok mass of carbon. So, mass of carbon. And then, dia ada berapa Carbon ada berapa dalam C5H5N tu? Ada 5 kan?
5.
Yes. Good. So, okay. Boleh buat. So, hydrogen ada. So, mass dia hydrogen 1 and then hydrogen ada 5. So, 5. Okay. Same for nitrogen. Nitrogen ada mass dia adalah 14. And then, darah dengan berapa banyak nitrogen ada? Nitrogen, we have 1. So, the total is, can somebody calculate it for me?
$79.
29.
Okay, so
The answer is 79.
79. So, remember, kalau dia cakap relative, dia tak ada unit. So, this is your final answer. Okay, boleh. So, let's go on average atomic mass pula. Apa tu? Apa tu average? So, actually, kalau kita tengok, kan tadi kita dapat average tu kan? Macam mana actually kita measure the mass? Okay? Takkan kita nak ambil penimbang. Kecil mana penimbang yang kita ada? So, what happen is, kita letak sample. For example, kita letak carbon sini. So, kita ionize the sample so we can get dia punya vaporized ions. So, you can have positive and negative ion. And then, kita akan shoot the ions, the positive carbon or negative carbon straight to this chamber. So, what happen now, kalau you tengok, dia, sebabkan dia ada positive and negative, okay, dia ada charge kan? So, dia akan tertarik kepada this electromagnet. This electromagnet ni dia akan curvekan the trajectory of the ions. And then dia akan curve, and then, Allah, saya ingat lah pula. Okay. So, and then dia akan sampai ke dia punya detection. So, how much the ion curve, okay, dia taklah curve macam ni. Ni just tulisan air buruk. Actually, straighter lah. So, how much it curve is that is what we measure. We measure dia punya mass per charge ratio. Okay. Kita tengok ratio berapa berat dia and berapa banyak dia deflect. Okay. Kalau lagi berat the ion, lagilah susah kan dia nak deflect. Dia ada inertia. Okay. Sama macam kereta. Lagi berat kereta you, lagi susah you nak corner kan. You nak belok. Okay. Let's see. This is apa yang you guys akan nampak lah. Okay. So, this is the mass spectrum of magnesium. Okay. Kalau dia cakap 1 magnesium, you ambil 1 block of magnesium. Alright. 1 block of magnesium. When you masuk dalam mass spec, you akan dapat banyak-banyak ni. Apa ni? Because dalam 1 magnesium ni, dalam satu magnesium ni, you not only have what's the most common magnesium. Magnesium is 24. 24 magnesium is the most common. Okay. Dalam this 1 block, you tak only have 24 magnesium. You also have 25 magnesium. And you also have 26 magnesium. Okay. Apa benda ni? Ingat tak tadi kita belajar pasal isotop? So, the mass of this magnesium are different. Even though they are still magnesium. So, dalam satu blok ni ada yang magnesium, mass dia 24, ada 25, ada 26. That's why we need to know the average. Okay. Kalau you tengok, dalam you punya periodic table or atomic mass, diorang akan always give you average. Okay. So, maksudnya, dalam this 1 block of magnesium, you have 63% magnesium 24, you have 8.1% and 9.1% of the other one. Okay. So, kita tengok, kita ambil average. Macam mana nak calculate average? What is this? So, Q is dia punya relative abundance. So, relative abundance. Okay. Kalau you nak tahu Q ni dapat mana is dekat part CY. Dekat part CY, that is the relative abundance. And this is the mass. So mass is dekat part Cx, which is mass times mass and charge ratio. Okay. So let's look at this and let's do the question. So kalau question dia akan selalunya tanya macam ni lah. Macam saya cakap tadi. So what are the isotope present in this rubidium? So dia bagi the mass spectra. So apa dia punya isotope? So we have 85 rubidium and we also have 87 rubidium. So mana I dapat ni 85 dengan 87? Mass. Okay. Dan beza berat dia maksudnya dia adalah isotop yang baru. So okay. What is the percentage of abundance in each isotope? Okay. So cara dia is, okay, tengok untuk rubidium 85. Tengok rubidium 85 dulu. So cara nak calculate percentage of abundance, okay, rubidium 85 dia cakap dia ada 18. So 18 over the total abundance. So 18 tambah 7. So dapat berapa? Calculate. So it is the same as untuk 87 rubidium. So it is 7. Dia ada 7 kan? Dia punya abundance. Over total abundance. So if you calculate, can you calculate dapat berapa? Dapat ke 0.72? Ayah, my 2 is a bit wonky. Dapat tak?
Dapat.
Okay.
Dapat sir.
The other one?
0.28.
0.28. So dia nak percentage kan? So you times by 100. So equal 72.0%, and this one is 28.0%. Okay, boleh?
Sir,
Yeah?
yang zero tu perlu ke sir? Wajib ke?
Okay. Is a good practice untuk letak, because sometimes ada, tapi kalau you tak letak pun tak apa. You letak 72 pun tak apa. It's okay. It's just a good practice for you to do it. So tengok relative atomic mass of rubidium, AR of rubidium. So the formula is summation of Qm over summation of abundance. Okay. Ingat kan? So this is abundance, this is mass. So how you feel it is, so the abundance is 18 times dia punya mass is 85. Okay, plus 7 times dengan 87, and then the summation of the abundance is 7 plus 18. So, you dapat tak? Dapat berapa?
85.56.
So, it's 85.56. Okay. For this, jangan lupa dia punya unit is AMU sebab, okay, for this, untuk dapatkan relative, you have to buat macam tadi. So 85.56 AMU over 1 over 12 times 12.00 AMU. So you cancel everything, so you dapat 85.56. Okay, this is just a formality. Okay, so nampak tak? It's just like we calculate the average from berapa banyak yang ada dalam tu. Okay, so this kind of question is selalunya susah sikit. Ya, kita ada masa ke? So I think this is gonna be our last question lah. So later I'll do maybe a video. I'll show it to you guys. So gallium has 2 isotopes So dia ada this one and this one. And the average mass of gallium is 2. So kita tengok any question yang kebanyakan question untuk metric question dia macam ni lah, dia tulis banyak-banyak. So apa yang you guys boleh buat, kalau you guys pasal nampak tak, I put this different color. Highlighter is very important. It's not just because nampak cantik, it's just to make sure that you guys don't termiss any kind of question, any kind of information yang dalam question tu. So dia punya mass is of gallium is 69.723 AMU. Okay, untuk isotop dia pula is, untuk isotop 69 gallium, so we have 68.9256 AMU. And untuk 71 gallium, we have 70.9247 AMU. Okay, and then for example lah, korang macam alamak tak tahu lagi nak buat apa. So I already have the information, but I still don't know what to do. That's why it's always important untuk tulis balik formula. Okay, relative abundance untuk isotope for dia nak relative abundance kan. So apa lagi yang you guys boleh dapat formula yang untuk dapatkan relative abundance. Okay, one thing yang I boleh ingat is dia punya AR is equivalent to summation of abundance times mass over summation of abundance. Okay, kalau you rasa dari sini kita boleh tak dapat relative abundance, kan? Boleh kan? So first step yang you guys nak kena buat is you guys nak kena isi lah. Tapi kalau you guys nak isi, macam mana nak isi relative abundance when you don't know how much pun ada untuk gallium ni or the other gallium. So first, this is important. You need to do assumption. Let's assume that the 69 gallium plus 71 gallium abundance is equal to 100. So the total abundance is 100. Okay, now let's assign dia orang punya andung. So let's assign that 69 gallium is equal to, maybe you nak letak X. Okay, kalau 69 gallium is X, apa is 71 gallium? 71 gallium should be 100 minus X. Betul tak? Because from this assumption, kita dah assume that, okay, imagine this is all of the gallium. Okay, so kita assume this one 100 kan, and then kita assume this is 69 gallium. So this 71 gallium should have X, so 100 minus X, so you akan dapat 71 gallium ni kan. Okay, so now we have established this. Kita akan boleh masukkan dalam dia punya formula. So we have AR of gallium, we already have 69.723 equal to the summation. So untuk 69 gallium we have X times dia punya mass is 68.9256 plus dengan 100 minus X, dia punya mass is 70.9247 divided by the summation of the abundance. So we have X plus 100 minus X. Okay, boleh selesaikan tak? Can you selesaikan and let me know the answer? Because this you boleh cancel. Kan? Boleh tak? Dapat tak the answer? So you should later get, since we are running out of time, so x should equal to berapa? Dapat tak berapa? 60.11.
60.1121.
Okay. So you nak ambil empat significant figures pun tak apa. So x is equivalent to abundance of 69 gallium kan? So kalau 71 gallium is 100 minus x. So it is 100 minus 60.11, you akan dapat around 39.89, betul tak? So this is the final answer. So jangan lupa percentage Sorry, saya lupa percentage. Okay, boleh. Kalau boleh, the final answer you guys tulis balik lah. This is your calculation and make your punya answer presentable. So percentage of abundance, So untuk 69 gallium and 71 gallium, so it should have 60.11% and the other one is 39.89%. Okay, everyone clear so far? I think our class, I'll end the class at this point. Okay, and then later I'll upload the what I've teach today on YouTube, and later on consultation hour, if you guys have anything yang you guys macam don't really faham, you guys can datang to me, so I'll make a room dekat kita punya server and I can teach you guys again. Okay, everything clear for now?
Yes.
Yes, sir.
Okay. So, okay, later I'll make a video on more concept. Kita akan masuk more concept. Untuk tutorial, you guys buat dulu sampai habis ni, sampai relative abundance and situlah sampai habis. Sampai 1.1 habis. 1.2 tu tak masuk lagi. Okay. So, jangan keluar lagi from the Discord. Everyone ada dalam Discord ke? Yang nak ambil attendance? Ada tak orang yang tak ada dalam Discord?
Ada, sir.
Okay, semua orang ada kan? Because now I wanna take your attendance. So everyone make sure ada dalam ni lah, dalam Discord. Kejap nak ambil attendance you guys. next time kalau siapa-siapa yang tak boleh datang or anything, let me know awal-awal Okay, 1, okay, 2. Okay, dah. So everyone here ada kan? Okay, thank you for coming to my okay, thank you for coming to my class. We'll see you tomorrow for the
Amali.
ni lah, for Amali. I'll brief you guys on Amali tomorrow. Okay. So for now, just
Yes,
do
sir.
the
Okay, sir.
tutorial.
Thank you.
Okay.
Thank you. See you tomorrow.
Thank you, sir.
Thank you, sir.
Thank you, sir.
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 Thank you, sir.
So